So this question, this one's a little ambiguous too, to some degree. The structure is probably for a student just learning this is probably overwhelming, but let's go through it. Hillary's teacher asked her to write a description of the transformation of the parent cosine function that would result in this function. So remember, all the stuff we've been talking about applies to cosine as well. So we would say that we could think of this as like h of x is equal to a cosine of b times x minus pi, whoops, not minus pi, minus c plus d. A does like a vertical stretch or compression depending on the value of A, and that also is the amplitude. B affects the period. C has an impact on the horizontal shift. And D has an impact on the vertical shift. And we're told or asked which statements are true. So there are statements in blue, and we just simply click on the ones that are true. So the first one says, to create the graph of h, the graph of the parent function is horizontally compressed by a factor of 1/2. So what they're really talking about, and so the impact on the period is also a stretch or a compression. So this does kind of like a stretch, oops, misspelled the word stretch, or compression by a factor of 1/2. So let's try to label things. So A is equal to -3. So that's going to flip it and stretch it horizontally, not horizontally, vertically, by a factor of 3. So that means that the amplitude is -3 or 3. And we'll talk about the negative sign in a second. B. Well, this is not written as B times x equals C. But remember on our last problem, to find B, B is just equal to 2. So what does that do when I multiply that by 2? Well, the period, what is the period of a function is 2 pi over b. So when I plug in my value for b, I get 2 pi over 2, which means that my period is just pi. Now on the, and it's the same for cosine. I said sine, but cosine is the same, but the period for cosine is 2 pi. If I graph that parent function, that period is 2 pi. So that means I went from a period of 2 pi to just 1 pi. So this is correct. It's horizontally compressed by a factor of 1/2. Then it undergoes a phase shift of pi over 2. Well, remember that C was an interesting one. We can find C because C is just it's just this number pi divided by b, sort of. But the phase shift is the opposite, right? So it would be like negative pi divided by 2, right? So the value for C, I guess let me erase that. So like on our previous problem, we said that C would be pi over 2, but when you plug it into the formula, that's a phase shift is the opposite. We're going to move to the left pi over 2 because that's how the formula is written. It's the opposite direction. So this is wrong. It's the wrong sign. And it says next vertically compressed by a factor of -3. No, you stretch it. You stretch it. You increase it. So that one's wrong. But then you vertically shift it up 4. Yeah, that's true because D is equal to +4, I believe, right? So this is our D value, which means you shift it up 4. So D equals 4. That means you shift it up 4 units. Then it says it has an amplitude 3 units greater than that of the parent function. Well, it's an interesting thing. Technically, yeah, the amplitude is 3, but it's a -3, so it's backwards, right? So because it's a -3, you're flipping it, right? It has an amplitude of 3 units greater than that of the parent function. And mathematically, that's not true. In the original parent function, the y value would be 1, right? So what I'm saying is, if we were to graph this, the regular cosine function goes from 0 to 2 pi. That's how long a period is. And then this is from 1 to -1. Now, to graph this thing, there's a whole lot of stuff going on. In fact, maybe I should just graph it in Desmos so you could see. So if I go into Desmos, I'm going to graph the parent function, and then we're going to change all these values, and you can see what actually happens. So when I say y equals, and I'm going to say y equals a cosine of bracket b this x minus c plus b. And then, oh shoot, you know what I did is I did that too quickly. Add slider a, cos b x minus c. It's not asking me for a b. So this is the parent function of slider minus c. All right. Okay. So on the original parent function of cosine, and let me just add that real quick. And then we'll change the color on this. So my A value normally is 1. My B value is normally 1. My C value is 0. And then my D value is also 0. So when I put my D value at 0, the two graphs line up. So what they're saying is we're going to do the phase shift, right? So the first thing is, according to this thing, the phase shift is negative pi over 2, which means C has to be positive pi over 2. So C being positive pi over 2, I'm going to make the step 3. 1/2 of pi is about 1.57. So I'm going to say 1.57. Seems weird. But then when I plug that in, if I change this to 1.57, what that does is it takes the original. Are you kidding me? So I'm going to say y equals a cosine of b x minus c plus d. All right. So when I did that, what happens is the red function is cosine, the blue function slides over a little bit just because of that change in c, right? Because it was a positive value. So it slid a little bit to the right, right? But in reality, it actually slides a little bit to the left. So then my phase shift is negative. Does that make sense? Because the formula is negative pi. So I have the negative of this. So my C value is really actually positive. So, but our horizontal compression is a factor of 1/2. Okay. And I said that our phase shift was negative 1/2. So I'm sorry, I went out of turn. So if I do this, whoops, and then our compression was B, which was 1/2 because B equaled 2. So if I change this to 2, see how that compresses that? Because it changes the period. So now my period goes from 2 pi to 1 pi, right? It's you get literally 2 cycles of the blue into 1 cycle of the red. Lastly, what we want to do is we're going to shift that up 4 units, right? So if I shift that up 4 units, it just slides up 4. But the last part that I really want you to see is this original y value is 1. Now, if my amplitude is 3, it does stretch, my amplitude goes up to 3 instead of 1. However, when I make it a negative 3, it's the opposite. In other words, if I don't do C at all and I don't shift it, this amplitude is negative. So that last one is not true. This last statement is not true. The amplitude is 3 units greater than that of the parent function. It is, but it isn't. When you think about the distance from the midline, it is 3 units bigger, but it's the exact opposite because of that negative sign, because it flips it, okay? Again, the reason I don't like this question is it's really ambiguous in the sense that are they asking for A, B, C, and D, or what the values of A, B, C, and D do on the graph with regards to shifting it from left to right. And that's the confusing part. But these are the correct answers.